Absolutely. All right, thank you very much. Hello, everyone. So yeah, today we're here to talk about Linux Qt and Android for embedded. So that's a small comparison, and hopefully you'll end up with a better view of what these two brings to that specific ecosystem. So a very quick introduction. So my name is Adrien. Yeah, I've seen it. I'm a software architect at Witekio, and we're doing software consulting. We really focus on embedded devices, embedded and IoT devices. So that's really our thing for a long time now. Hence that presentation, which really makes sense to us, comparing these two technology and sharing some of the feedbacks that we have about these two different platforms. All right. So first, let me say that both definitely make sense if you're developing an embedded application. Either you choose Android and use the full Android stack, or you go for Linux and Qt. These are two proven technology. They're used in a lot of different applications already. So the two will work. In our case, because we wanted to understand the difference, we actually, sorry, trying to use buttons properly. All right, because we really wanted to understand the difference between the two and share that with you, we asked ourselves that question, like what are really the benefits and limitations of each platform, which one is right for you? And to answer that, we wrote a white paper. And for that white paper, we used the same platform, same target application, same user experience, and two different OS and application stacks. So that's Android on your left and Linux on your right with Qt. As you can see, there's also like a little Linux penguin near Qt, near Android, and Qt above, because as you may know, Android is actually running under the hood with Linux. It integrates Linux kernel, and Android you can also use Qt for the application layer. So it's just for this one we're focusing on fully Android and full Linux Qt, but you have actually different technologies, and we're going to see that a bit after. So this was the team that we had when we wrote this white paper. So Julien focused on the OS part, and then we had two dedicated application developers for both the Qt application and Android, just to make sure that it was objective and not just the point of view from someone developing a Qt application or Android. And I'm doing both myself, so I'm able to present, but I'm maybe a bit biased toward Qt, to be totally honest. I believe that's okay for this presentation, but yeah. So this was the test application that we created for both environments. So that's the Qt application on the left, Android application on the right. You can see that they are very similar. There are some small differences, but overall, this is almost exactly the same user experience for both platforms. And I'm going to explain a bit more in detail some of the specificities that we saw. This application, the source code is actually open source. We have a GitHub repository where you can find all that. I have the link at the bottom left of this page, and we'll definitely going to be sharing that with you. All right, so from that, let's move to the OS overview. Then we're gonna have a look at the application and finally try to see what's the best fit for you and for your application. So we have these two OSs, and we said Linux, so really you have a lot of different options when you're doing Linux embedded. The industry standard right now is Yocto. You have other options like, for example, Ubuntu Core, Buildroot, and even more. And for Android, it's much simpler because you just have Android, and then you have specific flavor, for example, for automotive, which are Android Automotive. But otherwise, you have just the stock Android that you just then customize for your platform. So these are the two OSs that we're going to see. Yocto is the one that we were using for this white paper, and the one that we are using most of the time. And when you have to make that choice, really, usually, if you're not really familiar with embedded, Android will stand out because, you know, like you have or you may have Android on your phone. You can see it's working. It's got all these graphical interface, all these features. So it has that huge notoriety, and Linux is a bit like, it's a lot less visible. You have some phone actually running just a pure Linux, but it's not really comparable. But what you have to also to understand is that if you're just looking at your smartphone, embedded devices and smartphone are actually pretty different. Because when you're doing embedded, you really need to be able to customize what you're doing, to have access to the hardware and everything. And it's really just not the case when you're just, for example, developing a smartphone application. And developing an application for Android, which is again something very easy, is also something very different from developing the OS layer. And that's what we are going to talk about. So overall, it's easy to overlook some fundamental differences, but I'm going to explain that a bit more in detail. So for the questions, I don't know. The easiest is probably to do that just at the end of the presentation, if you have any, and I will definitely answer that. And yeah, even if we don't have the time, I will absolutely take the time to answer that for you. So let's compare these two. So first, we're going to have a look at the requirements of both OSs and the performance that you can have out of it. So if we start with, I'm going to show actually all of that. For this same platform, if you compare Linux and Android, you can see that there is actually a big difference. And the reason for that is Linux is a lot leaner than Android. When you're running Android, you have Android itself. So you have all the JVM, the runtime, the hardware abstraction, and you have, in addition, a Linux kernel running. While Linux is just the kernel plus the driver and the library that you add to it. So if you look just at the number, you have almost like, well, not almost, you have 4 times the RAM requirements, and that's mostly because of all the Java overhead and the Java JVM. The flash you'll need more, the boot time is much longer as well. I could also add that, for example, specifically for the boot time, and that's where we're really going to see the difference between the two. Customizing the boot time or reducing the boot time for Android can be actually very tricky, while the same is easy for Linux. And the reason for that is really when you want to customize Android, the stack for Android is huge, and because there is a lot of moving pieces, it can be very hard to actually achieve exactly what you want. So customizing Linux and achieving a smaller boot time, like 2 seconds, it's fairly easy. Android will start from higher, and reducing is actually difficult, and it's going to get more and more difficult as you want to reduce even more, of course. If we continue with performance, again, because you have the JVM and all the weight of Android, the performance that you're going to have with your application on your system are going to be better just on a small Linux system. And that seems pretty logical, right? So for this picture, basically, all the plus are on Linux side, right? Linux is leaner, so you have all the benefits associated with that. And Android has all these additional layers, which makes it a lot heavier to run and a lot slower. Now, if we look at off-the-shelf feature that they provide, the picture is a bit different. And starting from the graphical user interface, for example, if you look at stock Android, you're going to have a virtual keyboard, you're going to have Wi-Fi, Bluetooth settings, SD card brightness, like all the settings that you have on your phone, basically. If you have the hardware that is integrated with the Android OS, you're going to be able to control all of that directly. Now, that's an if, and we can talk about that a bit after. And you're also going to have the Play Store, which means you can install third-party applications. There is an asterisk here, because to be able to run the Play Store on your platform, your device needs to be certified. And certifying your device means that you have to go through that process, which is not free and can take quite some effort. So you have to make it to certify it with Google. And then you have your device certified and you can use the Play Store and all the applications that are on the Play Store, not before that. On the Linux side, I said poor to fair because it really depends what distribution, what tools you have out of the box. But with a default, for example, Yocto distribution, you're going to have almost nothing. You can have some dedicated desktop environment. For example, you could say, okay, let's use GNOME 3 or KDE Plasma or other, but that's going to be additional tools, additional framework that you're going to integrate in your image. By default, Android is just meant to be as small as possible. So because of that, out of the box, you really don't have anything and nothing the same for touchscreen. What Android is really optimized for that touchscreen user experience. If we continue with application development tools, again, it's easier for Android because it's got all these like very easy integration with Android Studio. You have all the deployment and debugging that are already present. So you have all that ecosystem in the Android platform because it just ships with all these features. For Linux, we're going to talk about that a bit more in detail after, but you can use Qt Creator and it has a great user interface. You can have a GDB, but you have to add it, for example. So again, there are development tools, but you will have to add them yourself. Out of the box, it's a lot smaller and it's going to be slightly more difficult than Android because Android really ships with everything out of the box. So there's some work to just make sure that your developers or you have the right tools to develop for your embedded device. Security on the left, again, we're a bit lower. It depends what you have. Android comes out of the box very good. There's again 2 stars here because out of the box it's good. You have permission per application, you have no root user, etc. But if you want to have, for example, an application that's able to install updates, then you have to have your application root and your device rooted. And this will pretty much defeat a big portion of Android security. So though it is pretty good out of the box, depending on the customization that you do after, you might have been in a situation which is actually not great from a security standpoint. And it could be easily lower than what you have for Linux. And Linux, yeah, you come with not a lot of things, but then you have a lot of way to make that a lot more secure. You can use AppArmor, AC Linux. You can use you can do the secure boot yourself, etc. So you have all these possibilities. It's just not there when you start. Same thing pretty much for updates. Android, you have the AD system update. So you can install a system update and fail over and something goes wrong, go back to the previous one. And you have all these application package management with APK. So if you generate an application, you pretty much already have the update system, right? With Linux, you have that only if you have a package manager and only if, for the application that you will generate, it will not be integrated in this package manager. So that's something that you'll have to do manually. So again, there are tools for that. And for embedded, typically we're using tools like Rock for the package install. There are also tools like SW Update, OS3, Mendel. It's just additional pieces that you will put in your Linux distribution to support updates in a way that makes sense for embedded devices, because with embedded devices, you have to be power failure safe. For example, if something goes wrong, you have to make sure that you can roll back automatically to an update that works to previous version of the system. So for this picture, really, it seems like it's a lot easier for Android. Android does provide a lot out of the box, and that's one of the big strengths of Android for that. For Linux, you can do pretty much the same, but you have to know or to find which tools to install on your platform. And most of the time, you have to do that yourself. And now the final point, and it's really going to be what separate them, because so far we've seen that there's plus for Linux performance-wise, there's pluses for Android and feature-wise. But if you look at the build and customization process, which is quite important because when you have an embedded device, you will have to build it yourself, and you will have to also customize it to adapt to your hardware and to exactly the way you want it to behave. So looking at the building process first, building a Linux distribution for embedded can be pretty easy if we talk about Beetroot, for example, a bit more difficult if we're talking about Yocto. But overall, it's going to be simpler than Android. Because Android has all these different layers, and you will have to build that. It will take hours for sure, and it has dozens of repositories that you have to clone, build, and then deploy. So the build process is definitely more complicated. And if you look at the customization specifically, it's a lot easier to customize a Linux distribution because Linux is meant to be customized to be hacked. So you can do that very easily for Linux. And that's really the big difference. For Android, that will be a lot harder. So we have a lot of working with a lot of customers, and they will have their Android platform, and they will need, for example, to customize something as simple as the way that you, for example, enter text in an application, and we're even talking just the application here. And just doing that means that sometimes you have to go into Android codes, Android layer to change really how it works, which is fairly difficult. And if you want to, for example, add canvas, it's not supported out of the box, and adding that is going to be very tricky. So as soon as you want to customize something, either add support for hardware or add new feature or modify the way Android works, it is a lot of work. So that's pretty much what I said, but if you want to support, for example, a component that's not supported out of the box by Android, let's say you have a custom Bluetooth chip that you want to support that's not supported by Android, doing so is pretty easy with Linux. It's a lot harder with Android, and it's even harder if you want to support something that's not integrated by default in Android, like Canvas, for example, which is not part of what you have on your smartphone, except if you have a very weird smartphone that's not the same as mine. But otherwise, that's really not something that comes with Android. Updates tends to be more frequent with Linux and less frequent with Android. It applies also to kernel updates. So security-wise, it's a bit easier for Linux. And the community and documentation the community is larger and there's more documentation on the Linux side. Android, they are some people who are really expert in that field, but it is much more limited, and there are some documentation, but again, it's also more limited. Same if you look at the number of books, there are a lot more books on one side than the other. So that's going to be the end of the OS part of the presentation. So far we can see that Android distribution or an Android system is really great when you want to use the feature that it provides out of the box. If you want to do something more, or if you want to really customize the way your product behave or add support for hardware that's not supported, then you definitely want to go with Linux. And we're going to see that also at the final recap that integrates the application part. And there's also a summary, which I just did a minute ago. But yeah, Linux, you have lower hardware requirement, much easier to customize, but more limited off-the-shelf feature. Android OS, you have more off-the-shelf GUI features and features in general, but much higher hardware requirement and a lot more difficult to customize. So from that, let's move to the application part of the test. And we're going to start with the stack that we have. So if we look at the application stack for Linux and Qt, So you probably already know that if you're familiar with Qt, but Qt is based on C++. So in our test, we use Qt for the logic and GUI, and we use Qt Quick for the graphical user interface and the C++ API. You have also Python that you can use to directly create a Qt application. And on the right side for Android, we use the native Android Java and Android XML user interface, but you can actually also use Qt for that. And you can use Flutter, Kotlin, Dart. There are a lot of different options that are actually valid on Android. So let's start with the comparison. And if we look at the community side, again, community size, Qt has a fairly large community. It tends to be a bit larger for Android just because it is more accessible. But it's really not a big difference. Looking at the stack itself, it's pretty similar. You have on one end C++, Qt Quick, on the other side, Android Java and Android XML. So you have that same kind of separation of the graphical user interface and the logic that you have behind it. One big difference, however, is that Qt obviously is cross-platform. I haven't listed all the different options here, but you can run Qt on, I'm going to say, pretty much any device. And that's obviously not the case for Android. So if at some point you want to build something that's cross-platform, it's definitely easier to be just developing an application with Qt directly. The integration part of the design is also easier with Qt because now you have a tool that's called Qt Design Studio. And Qt Design Studio lets you import directly from Photoshop and Sketch. So it tends to make our life as developer a bit easier because then you can just have all the resources exported and just ready to use with all the animation and just focus on the logic that's needed for the application. Android does not have that out of the box. You can use tools such as Zephyr to export to and provide all the resources and everything, but it tends to be a little bit less integrated than just Qt Design Studio, which provides everything. If we look at navigation and history, so navigating in your application and doing back, for example, that's very easy on both sides. If you're using Qt Quick, you have the stack view. If you use Java, you have Jetpack navigation class. So no big difference here. And the last category of this part was the composition of the graphical interface. Again, both are pretty similar. One big difference, however, is that Android does not have JavaScript as we have for QML, which means that if you have a component that you have to slightly customize for different views, for Android, you will have to create different separated components. For Qt, you can easily do that with just a bit of JavaScript and change the way things are on the screen. And for the second part of this comparison, it's pretty close. We have, I'm going to move a bit fast because time's passing. You can see that file browsing, file manipulation, data model, etc. We're pretty close. Qt does provide some more feature for models and filtering, but overall, it's not a big difference. Android is a bit more integrated for multimedia feature, but again, nothing big. And it does provide some more advanced accessibility feature, but Qt also has features just to make your application accessible. Internationalization, they're pretty much the same on both sides. Qt does have Qt Linguist, which is great for translators. Android does make it slightly easier for developers. So overall, it's a tie. If we look at the development environment, both are pretty similar. Android Studio is going to be more integrated just because it targets one platform, but both are very good options. So again, with either, you're going to be in a good position to develop your application. And if we move on to that final comparison, basically the story is go with Android if you really are developing something that is a smartphone or smartphone-like device, or if you want to use the Play Store or some very specific features from Android, like for example, there are some VR feature that you may want to use specifically for that and all the tooling around that. But be aware that the Play Store requires certification and it's not nothing. And if you don't want to use the Android user experience, or if you want to customize it just a bit too much, it's going to be actually a lot of work on the US side. So easy application development, great integration with Android, of course. And you have a lot of OS feature, but the cost of customizing it for your hardware and customizing the behavior might be very high. And usually that's what's not expected by the people and the customer we see coming to us. And go with Linux and Qt if you're developing anything but a smartphone, basically. If you want something that's leaner or just have a customized user experience or customized behavior. So you have, again, easy application development, cross-platform, small hardware requirement, and it's much easier to customize the OS and the hardware. And as a plus, if you have a C++ application, it's a lot easier to access everything directly, while a Java application, you really have a lot of abstraction, so it makes it a lot harder to access your drivers, for example, or peripherals. And that's it for that presentation. Thank you very much. So 2 things you can do, definitely connect to us. I'm gonna have a look at the questions. So I'm on LinkedIn and Twitter, and we have that white paper that's on the Qt website. So feel free to have a look and download the full comparison. And yeah, that's it. Thank you very much for your attention.
Thank you, Adrien. So if you still have questions that you want to ask Adrien, please use the Q&A box, like Saif. When is it, oh, I like that question. When is it interesting to use Qt together with Android?
Okay, so yeah, it is a good question. In my experience, is a very good mix of technology, either if you are familiar with Qt and C++, because if you are familiar with a technology stack, that's always easier to go with that, except if you are part of a larger team, but that's definitely one reason to go with that. If you are building a cross-platform application, that's also very good to have a Qt application because it's cross-platform. You can use it on that device or a different one. If none of these 2 apply, you might be, it might be because you want to integrate something that is C++, or you have code that's C++ that you want to reuse. And that's going to be a bit easier with a Qt application. But if you're not developing cross-platform, not necessarily familiar with Qt, or you don't have that C++ application, then it's probably just easier to go with an Android application because it's going to be more integrated into the whole Android stack.
Okay, we have another question by Niels. He asks, how can Android audio priorities be done in Qt multimedia? For example, stop playback of media on an incoming phone call?
That's a very good question, and I can tell you that I don't know. I can definitely have a look, but I can tell you that I don't know. Sorry.
Did you have any more questions, Adrien?
No, the one I wanted to address was actually the one with Qt and Android, because it's definitely a good question that we see often.
Right. We have, I guess we can take one more. Is there a difference between embedded development experience with regards to open source and commercial?
It's gonna, So it depends in regard, I mean, when you're developing an embedded product, if it's a commercial product, I'm trying to see how to compare that, but you can use the open source or the commercial license for embedded development, no problem. If you are developing a commercial product, then you have the limitation of the LGPLv3 open source license. So it's definitely something to look into. And if it is, basically one of the main clauses of the LGPLv3 is the entity-ization, which means that for some device, you have to provide the full environment to rebuild the whole Qt stack and provide that to your customers. So that's entity-ization and LGPLv3 clause does definitely apply to some embedded devices. That's something that has to be, I would say, studied more in depth with a lawyer if you want to go that route. Otherwise, there's the commercial option, which works great, and that way you can just keep all your code closed source and have access to the other tools that Qt provides.
There's one more. I guess we have time for that one. Witekio says, is the support for WebAssembly in Qt Android? I guess, could it be, is there support for Qt for WebAssembly together with Android? Merci beaucoup, messieurs. C'était intéressant. Let me translate that for you. He means to say thank you. But gentlemen, it was interesting.
Yes, yeah, Martin saw that I was French. So, I mean, WebAssembly is really, you are compiling your application to run in a browser. So there is support for that, or at least preliminary support, as far as I know, for Qt to do that. But if you mean running it, so it really applies to running some code in a browser. So if you're running Qt on Android, you pretty much don't need WebAssembly. If you mean running WebAssembly in a web view in a Qt application on Android, then you can probably do that. Qt is based on Chromium and it's updated frequently. I never tried. I don't know if it makes sense as is. It's either you go with WebAssembly because you want to distribute that online, or you go with a native application. But combining both, I'm not sure I see use case, but maybe there's.
Yeah, now we're getting all those questions. Let me see when the next one is. No, it's good. It's good. Keep them coming. I'm just checking if we have time for them. The next one is at 17:30. So yes, we do have time. Do you have time?
Yes, absolutely. Yeah.
Let's see. Have you checked the performance between Android, Qt, and Ionic 4?
Yes. So if you, in general, well, at least in the past, Qt was the technology with Qt Quick that provided the best performance out of the box. If you're running on Android specifically, now the difference between the two is a bit closer, but still, because Qt is natively accelerated and all C++, it tends to be faster than a native Android application, which can be counterintuitive actually. Ionic will, in our experience, tend to be a bit slower than Android, just because you have all that that web stack that you have to run in addition to that. You could do something where you actually using Qt plus WebView or Chromium to yeah, well, no, that would be a bad idea. Let me take that out. But no, so in general, if performance-wise, that will likely be Qt first, Android second, and Ionic at the fourth one, at least in our experience.
Is it possible to add your Qt Android app on the Play Store?
It's, let me see, it would be possible, but then it means that we wouldn't be able to deploy it to our device because the device that we use is just like a development platform. So it's not certified, so we don't have the Play Store. But I mean, I can, yeah, the code is open source. We can definitely see if we can put that on the Play Store.
Is it possible to add your Q? Oh no, I read that one. Is the UI development in Ionic easier than Qt? The first has HTML and CSS, and it's easier than something that seems more cumbersome.
It really comes down to your preference and your familiarity with the technology set, right? I don't believe that Ionic is, it might be slightly easier to integrate with Android, but beyond that, like if you're using Qt and a QML, for example, the QML and the way you create your user interface is actually pretty straightforward. And that goes for the layout of the GUI and the graphical, the style sheet, like you'd say, customization of the colors and everything. I find it very intuitive. Ionic does, like you say, is based on HTML and CSS. If you are familiar with HTML, CSS, and this technology set, it's going to be easier for you. I don't believe it's easier. There's a big difference in general, but yeah, going with the technology that you're more familiar to definitely makes sense.
Here's a use case question. Are you ready for it?
Yes.
So controlling an embedded device with a remote GUI with the controller and logic running on the device, but the UI running on a tablet or smartphone, what could be a good solution?
No, controlling a device. Okay. Okay. So the first that comes to mind is if you are on the same network, really, one very easy way to do that is to just have a web server running directly on your device. That could be either a web server or that could be Qt provides two tools. They are my memory of names is pretty bad, but I could find that back to you. Basically using WebGL or streaming the GUI to another device. That's something you can do. So you can do that either with Qt technologies and it's like streaming your user interface. That's possible. And you can do that also with just a standard web server that you run on your embedded device. And in both cases, connecting to it from your smartphone. If you have a standard web server, it means that you don't even necessarily need an application running on a tablet or your smartphone. You could just like connect to a specific IP or just like an NFC tag on your device and boop, connect to it. That will work. Or you could have also a native application. And that would be if you want to have a more polished, very responsive user interface, that would be the best way to go. So I guess if you have something that, if you have a Qt application, you want to reuse it, Qt can let you stream the user interface from the device to a smartphone. If you want to do something very simple, then a web server with a simple web app running on the device and connecting to it directly would definitely work. And if you want a more polished interface, the more polished experience, that would be with a native application on your smartphone or tablet. And then you can use BLE or Wi-Fi, and there's a lot of things you can do for the communication then.
Oh, look at that. That was some free consulting right there. Great. I think we have one last question. Is there a difference between embedded development experience with regard to open source and commercial?
For the development experience, Okay, so that's a tough one, but simply because I need to refresh my knowledge of what's in the commercial license and what's not every time. But in general, I would say if it will be easier if you have a commercial license, just because the commercial license, well, you have support with it. You have the QML compiler. I don't remember if it's in a commercial license or not. But there's the QML compiler. There's the QDesign Studio, the virtual keyboard. I don't remember again in which category it falls, but basically there is different components and different features you will have only with the commercial license, plus support from the Qt team. So going with the commercial license will make that easier, and just because you will have more tools available. And there's also one additional use, which is the boot to Qt feature. So boot to Qt is basically a BSP that comes out of the box pre-configured to run your application. And that's another option. But overall, yeah, comparing the two, using the commercial license does provide some features for developer.
Great, thank you very much. Thanks for sticking around and answering some additional questions. Any parting words?
No, I mean, that was great talking to all of you. Yeah, feel free to connect with us. Feel free to download the white paper and let us know what you think of it. And you can ask me questions directly on LinkedIn and Twitter if you want, or here. And I will be happy to answer.